Hello my dear students, today we discuss about the topic vector analysis from the unit 6. In the study of physics, we came across a large number of physical quantities and they are classified into scalars and vectors. First we can see scalar quantities. The physical quantities which have only magnitude but not direction. The quantities which have only magnitude but not direction, they are called scalar quantities. Example for scalar quantities is mass, length, time, speed, temperature. Next, the vector quantities, the physical quantities which have magnitude as well as direction are called vector quantities, and they follow the vector law of addition. The quantities which have both magnitude as well as direction, they are called vector quantities. Example for vector quantities is displacement, velocity, acceleration, force, torque. After the scalar and vector quantities, now we can see representation of a vector. An arbitrary vector such as A, denoted as A, is represented by a direct line segment as shown in a figure. O is called the initial point, and P is called the end point of the vector. The length of the segment OP represents the magnitude of the vector. The length of the segment OP represents the magnitude, and the arrow at the end point indicates the direction. The length of the OP indicates the magnitude. The arrow at the P end indicates the direction of the vector. Here we see the vector A is equal to OP. The magnitude of the vector A is equal to OP. Now, after representation of the vector, now see types of vectors. First one is zero vector. A vector whose magnitude is 0 is called a zero vector. It is denoted by O or A dash. This is nothing but the end and start point is coincide with each other. Both terminal and origin coincide for the zero vector. This is called zero vector. Second one is unit vector. A vector whose magnitude is unity. Unity is nothing but 1. That is equal to 1. It is called a unit vector and denoted by vector is equal to 1. Unit vector along x, y and z coordinates axis are represented by I cap, j cap and k cap respectively. This is x, y, z. Along x direction I cap, j cap, z cap respectively. These are the unit vectors along the x, y, z directions. Now the next type is equal vectors. Two vectors A and B are called equal vectors and they written as A equal to B in if and only if they obey these two conditions. First one is both are in the same magnitude, both are in the same direction. First one is both the vectors have the same magnitude and both are in the same direction. If the vector obeys these two conditions, then we call those two are equal vectors. Here in the figure we can say A, B, vector A, vector B, AB and PQ. Both are equal vectors because the direction is also same and magnitude are also same. Thus, A vector equal to B vector when AB is equal to PQ, magnitude of AB is equal to magnitude of PQ. And the next type is negative of vector. A vector equal in magnitude but opposite in direction to a given vector is called negative to a given vector and denoted by minus a. Here we in the see figure AB, vector AB minus a CD. Here the magnitude is same but the direction of the vectors are different. So AB is in this direction and CD is in this direction. So we can call it as negative of vectors. Thus vector A is equal to AB minus vector A is equal to CD. But the magnitude is same. By this direction is different. Then next type is coinitial vectors. Vectors whose initial points or origins coincide are called coinitial vectors. Here we can see the figure. O is the origin, OB, OA, OC. These are three different vectors, vector A, vector B, vector C. But these three are same origin O but different endpoints A, B, C. This is called coinitial vectors. Now the next type is position vector. Position vector is very important for your next topics. If P is any point in a plane or in a space and O be the origin chosen, the vector R equal to OP is called the position vector of a point P with representing the origin O. Now let's see in this figure, below figure. P is any point in the space. P is any point in the space. O is the origin. The vector OP, the line OP is a vector R, is position vector of point P. Position vector of point P. R is position vector of point P. And this is how the position vector can be determined. Then now the next topic is addition of vectors. Addition of two vectors A and B according to the two laws. First one is triangle law of addition and second one is parallelogram of law of addition. First one is triangle law of addition. For this, consider two vectors A and B which are the same nature, nothing but same magnitude. Let AB and BC represents the vector A and vector B respectively. AB represents vector A, BC represents vector B respectively. Let the triangle ABC completed by joining the AC. Then the sum of vector A and vector B, that is equal to R vector A plus vector B, or magnitude AC is equal to magnitude of AB plus magnitude BC. Vector A, vector B. By joining these two with a C, this is the sum of vector A and vector B. The resultant vector is R is equal to A, vector A plus vector B. This is triangle law of addition. Vector A, vector B. The sum of these two, vector A and vector B, is given by the line joining between A and C. This is called vector R. The next law is parallelogram law of addition of vectors. For this, consider two vectors, vector A and vector B, which are the same nature. Let AB and AD represents the vector A and vector B respectively, with AB and AD as adjacent sides. Let the parallelogram ABCD be completed, then according to the parallelogram law of addition of vectors, the diagonal AC of the completed parallelogram ABCD represent the sum of vectors A and B, that is denoted by vector R of two vectors. Here vector A, vector B are two vectors. AB and AD are adjacent sides. Now we can join DC and CB. Now we can join the AC. Here this is vector R. The sum of A and B is given by vector R, which is the line given joining the A and C. Here we written is the addition of A and B is given by vector R is equal to vector A plus vector B. R magnitude AC is equal to magnitude AB magnitude AD. This is parallelogram law of addition of vectors. After the addition of two vectors, now we can see subtraction of vectors. If vector A and vector B, any two vectors with same type, the subtraction of B from A denoted by A minus B is defined as vector A minus vector B is equal to A plus of minus B, because the magnitude is same but the direction of the vector A and vector B is different. So we can write this type. Here in the figure we can see vector A in this direction, vector B is in this direction. By joining these two, the resultant vector R is gives the subtraction between A and B. Here the resultant vector A plus of minus B is equal to subtraction of two vectors. Vector A and vector B. Subtraction of vector A and vector B. Here the magnitude is same. The magnitude is same means AC equal to AB plus BC. The magnitude is same for subtraction of vectors, but the direction is different. So you can subtract A minus B. Here the resultant vector R is here. So this is the introduction about vector analysis. In the next class we can see next topics in our next video.